Hi everyone, in this video we are going to discuss how fats and oils operate within the human body. So let's start off by reviewing what fats and oils are, and we're going to start with the most global term that we've discussed, which are lipids. So now at this point, even though I've said it over and over and over again, hopefully we are all on the same page where we understand that lipids are fatty acids that are insoluble in water. Now we break lipids down into what are called triglycerides. So we know that we can synthesize triglycerides by taking 3 fatty acids, treating them with a glycerol molecule, and we can create a single triglyceride in addition to 3 water molecules. Now, what we can do is we break these triglycerides apart into either what are called fats or oils. Now, from previous videos, we know that fats have melting points that are greater than 25 degrees Celsius, whereas oils have melting points that are less than 25 degrees Celsius. We also know that fats are solid at room temperature, whereas oils are liquid at room temperature. Previously, we've said that fats are usually saturated, meaning they have all carbon-carbon single bonds, where oils are usually unsaturated, meaning that they have at least one, if not more, carbon-carbon double bonds. And the last thing we want to add here is that we consider fats to be unhealthy, so we want to avoid those in our diet, whereas we consider oils to be the healthier option of the two. We absolutely need to eat these. A lot of people just want to cut fat or have a no-fat or low-fat diet. That's not healthy for you. You absolutely need to have fats and oils in your diet, but you just want to lean toward the oil side because it's definitely healthier. So the one thing I want to point out before we look at this chart that's creeping up on me on my slides is that the human body is absolutely wonderful. It is just absolutely magical. And the reason I'm saying this is that the human body can actually create all fatty acids, except for 2, from ingested foods. So what it does is as long as we eat a regular diet, our body can take everything that we eat, grab different components from each one, and actually synthesize every fatty acid that is needed. The only one that we don't have the proper starting materials to do that for, the only 2 that we don't have are linoleic acid and linolenic acid. Okay, so we have 2 of them. All right, these 2 our bodies just cannot synthesize regardless of whatever we eat. So let's look at a little table that highlights the composition of a bunch of different oils and butters. So you can see at the very top, we're looking at something like canola oil or flaxseed oil. In the middle, we have something like lard. And then all the way here at the bottom, we're looking at our coconut oil. So these are the 3 I just highlighted. So on our left axis, we just have a list of different oils and butters, or lards, I should say, or fats. And then on our x-axis, we have our fat oil composition, but specifically we're highlighting the number of grams per tablespoon of fuel. So either fat, oil, whatever we want to talk about it. And then the last thing I want to highlight is the key over here, or the legend over here on the right side, where it breaks down the different bars. So what do these different colors mean? The blue means saturated, which remember is your carbon-carbon single bond only. Monounsaturated, meaning there's at least one carbon-carbon double bond. And then our 2 components, our 2 acids or fatty acids that our body cannot synthesize, so we're really looking at these reds and greens, and then other, just whatever composition's there. So the thing that you want to be able to do is look at a chart like this and immediately see, okay, I know why people are always talking about coconut oil. Coconut oil is very, very healthy for you because it has a lot of saturated fats in there. Is that healthy? I don't know. But it also has another component in there. If you can see now, you're going to see you have the linoleic acid and also the linolenic acid in there, which is a huge, huge contribution. But my question is, of these acids, and I'm going to give you a list of these, which one is the best to supplement our diet? So which of the following and I'm going to just put foods, but really what I'm illustrating are either oils or fats. Okay, so which of the following foods would be the best option to supplement our diet? To supplement our diet. So now remember, if we're supplementing our diet, it's because we have a lack of something. So we're really trying to highlight the fact of those 2 fatty acids that we cannot just create or synthesize inside of our body. Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. all you had to do was look at this graph again and see if you could actually determine how much red and green each one of these systems have. Now, I asked you to analyze 4 different ones: canola oil, flaxseed oil, lard, and butter. So hopefully right away you could look at lard and butter and say there is no way that that's going to be a good option for me because it does not have a lot of my linolenic acid or my linoleic acid. Okay, so my lard and butter, gone right away. Now, the other two, canola oil and flaxseed oil, actually are both fairly decent options. But what I see immediately with flaxseed oil is that huge green bar. So I know that I have a lot of linoleic acid, linolenic acid in my flaxseed oil. So that is the beautiful, wonderful substitution. Canola oil is fine, but has a lot of that monounsaturated fat where we want to try to avoid that a little bit. So, in order of what you want to eat to supplement your body to get those 2 fatty acids, you definitely want to get flaxseed oil. I also want to highlight our soybean oil and corn oil. So, both of those have some of that extra fatty acid in there. So, if you can, please try to kind of add that to your body as well. Maybe a little bit of sesame oil to mix it up, but you definitely want to make sure you're getting that well-balanced diet. Now, the issue with this is that a lot of these oils have a very short, relatively short shelf life. So they decompose or they turn into bad things, right? They have all these impurities in them. So what we do is we use this process called hydrogenation. So essentially what happens is that we have an oil and it can be converted. So an oil can be converted to higher saturation using the process called hydrogenation. So there's 2 things here we need to talk about. The first thing, higher saturation. That just means you're removing some of the carbon-carbon double bonds. So I'm going to write fewer carbon-carbon double bonds. So if you move to higher saturation, it's saying you're eliminating some of those double bonds and you have more carbon-carbon single bonds now. Now the process of hydrogenation is actually what I'm going to draw out here for you. It's not very complicated, so don't get freaked out by any means. But hydrogenation is a simple conversion of a carbon-carbon double bond to a carbon-carbon single bond, but there's 2 pieces to this. You need to use a catalyst, and you must use hydrogen gas. Okay? Hydrogenation, hydrogen, think hydrogen. Okay, you need a catalyst, you need hydrogen gas. So let's draw this out very simply. So let's talk about, we start with this carbon-carbon bond. Usually we have hydrogens on them, and then I'm going to use our generic R again. So reminder, generic R just means there's something else. There's other chemistry going on there, but it's not important, so we use the R. So we have our alkene, right, our double bond. And then what we do is we treat it with hydrogen gas. So H2, right, just this. Or we could have written H2 gas. Sometimes you'll see it like this. But we're just going to do the hydrogen double bond here. We also have to add a catalyst. So we're just going to write catalyst here. And what happens is we basically hydrogenate. And so we add hydrogens to that double bond. So instead of having a double bond, now we've increased our saturation. So it's completely a single bond. And so we have 1, 2, we don't lose our R, okay, the R's stay the same, but now we have 1, 2 hydrogens here as well. So we've gone from a system that had 2 hydrogens on it to now a system with 4 hydrogens on it. This process is called hydrogenation. And if you do this to oils, it increases the shelf life because you're very slowly trying to force that oil to operate more like a fat does. So a lot of times you'll hear them say they use hydrogenation to increase the shelf life. That's very common. But otherwise, you'll hear people say, oh, we use hydrogenation to make the oil more spreadable. Now, more spreadable, just think about margarine or butter. It's something you can easily spread onto a piece of toast or bagel or whatever it is that you want to use. But it's spreadable. It has that thick, solid-like property. It's not an oil like a liquid that's going to just make your substance, whatever it is you're eating, disgusting, right? So it's more spreadable. Okay, now what I want to do is show you a little diagram here. Here's where we take our linoleic acid, we treat it with hydrogen gas and a catalyst, and what we can see is that we automatically remove this first carbon-carbon double bond. So this becomes a carbon-carbon single bond. Here's your double bond, right? So all you're doing is adding 2 hydrogens two right here, one's there, one's here. So where it used to be, where that double bond used to be, we're adding hydrogens to it. This is something that often happens in peanut oil. You'll see that a lot. But this process of hydrogenation most often happens with our margarines, our butters, or anything that you want to put into candy bars and make them absolutely delicious. All right, the last thing I want to point out here is that we can also classify fats and oils by structure. Okay, so before I move any further here, I want to ask you a simple question. What is an isomer? Go. All right, did you get an answer? Hopefully you did. This was just a review question. So hopefully we can remember that isomers have the exact same molecular formula, but they have very different structures. And the reason I wanted to review what isomers are is because we need to talk about the difference between a trans and a cis fat. So hopefully you've probably heard of trans fats before. So what we need to do is just draw out something very simple, like a carbon-carbon double bond. And then what I'm going to do is show you these two different isomers. So for this example, I'm going to put my chlorines and my hydrogens on opposite sides for my trans structure, but for my cis structure, I'm going to put them on the same side. So what you can see here is that in a trans structure, they are on opposite sides, what are considered to be opposite sides. So if they were the same, that's what cis would look like. They're both up here. So up, up, down, down is a lot of times what you'll hear. And so something that is two pieces on the top side, if they're together basically or the same, that's what's considered to be cis. If they are on the opposites, you have one up and one down, or one up and one down, that's considered trans. And trans fats are really, really bad for us because they act a lot like saturated fats. So now we're going to talk about what saturated fats are. So saturated fats and trans fats are super, super bad for you because they stack. So if you recall, our saturated fats we said are in this tubular structure. Same thing for trans fats. What they do is they end up packing on top of each other super, super well. They have these really high dispersion forces. So they have these really neat interactions between each other that stack and comprise them and pull them in together really closely so they can pack very, very well. However, a cis molecule cannot, because they've got ends sticking out everywhere. They cannot easily pack, and they're not nice and flat. They can't pack on top of each other. Instead, it's like all these different crazy structures trying to max on top of each other, and there's just a lot of holes. You can't get as many different of the pieces, whatever molecule it is, together on top of each other. So why is that a problem? Well, think about your arteries. If you have a lot of fat that is stacking on top of each other in your artery, it's going to form a blockage. That's going to cause problems with your heart. It can be problems with your blood pressure. It's a huge, huge issue. And so what happened is the United States has banned trans fats from our system. You are not allowed to sell something that has trans fats. And our U.S. law specifically, because I don't want to mislead you, the U.S. law says that you must have less than 0.5 grams of trans fat per serving. So I want to alert you to this because legally in the United States, they can sell you things that have trans fat as long as they make that serving really, really small. So check your serving size on that nutrition label on the back of your packages. Especially look at your Doritos, look at your potato chips, anything that tastes absolutely delicious and greasy. You want to make sure you're not getting a lot of trans fats because it's bad for your system. And what's really neat, Denmark was actually the first country to just ban them altogether. So way to go, Denmark. Shout out to Denmark. Love that. All right, so now, why am I talking about this after hydrogenation? Well, the issue is sometimes with hydrogenation, let's write this out because I think this is important. Hydrogenating cis oils can result in trans oils. So what we need to do is be very, very careful because even though what they're doing is they take something that is a cis oil, so it's a double bond, and they're trying to hydrogenate it. So they're trying to eliminate that double bond and make it a single bond. That doesn't always work perfectly. Sometimes what happens is you just reorder the structure, and so you basically flip one of the carbon molecules, so that instead of having your hydrogens on the same side with a cis geometry, instead now you've flipped it so the hydrogens on the other side, you've now created a trans fat. Your trans fat can stack really well and clog your arteries. It's a big, big, big issue. So we have to be very careful when we're talking about hydrogenation reactions. The last thing I want to point out is that you can use this process called interesterification. Woo, that was a hard one for me to get out. And you can do the same process where you can scramble your triglycerides and you essentially create new triglycerides. It's a very, very cool process, but it's something that's complicated, and it's just something I want you to be aware of. But please, if I can't even say the word, I'm definitely not going to test you on the word. All right, the last thing I want you to do, I know this is a long video, I'm sorry about that, I do apologize, but the last thing I want you to do is actually do a calculation, all right? So now, movie theater popcorn usually has 6 grams of trans fat per serving. So now, for the sake of this argument, we're going to assume the serving is 1 bag of popcorn. So let's say you binge out, you've had a horrible night, for whatever reason you're studying, and you've decided to eat 4 bags of popcorn. So you eat 4 bags of popcorn. My question to you is, how much trans fat in grams, okay, have you eaten? So I'm looking for trans fat in grams. What is the mass of trans fat that you've just eaten? Go. All right, did you get an answer? Hopefully you did, and hopefully all you saw is that, oh my gosh, popcorn, especially movie theater popcorn, can be really, really bad for me. So what you do, you eat 4 bags of popcorn, multiply that times our 6 grams of trans fat per every serving, which we're going to say is 1 bag, and this gives us 24 grams of trans fat. That is so bad for you. It is so, 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 so bad for you. Please, please never binge eat your movie theater popcorn. If you're going to eat popcorn, do not have the butter on it. Do not put anything else on there. Popcorn's a beautiful, healthy snack for you until you start adding your fats and oils. Have a great week. Take care of yourself. Eat your veggies.